Whenever an acid reacts with a base, it is something called a neutralization reaction. Neutralization basically means that it's going to become more increasingly neutral, but not necessarily neutral. If we have equal strength acid and equal strength base, then they would neutralize back to a pH of 7. But if we have a strong acid reacting with a weak base, then we will still have a neutralization reaction, but it will not result in a product that is a pH of 7. So it doesn't necessarily mean we're going back to 0, or I should say 7, neutral. It just means that it's a reaction between an acid and a base. Now, a neutralization reaction are pretty easy to predict because they always produce the same two products. Basically, every single time we're going to produce water, and we're also going to produce some sort of salt. Now, salt is just another fancy way of saying an ionic compound. This does not necessarily mean table salt, but an ionic compound is often just and generally called salts. So we're going to make salt and water. So all we need to do is find where the water comes from, see whatever's left over, and put that together in a correct ionic compound to make the salt. So these are really quite simple. In this example here, we have acetic acid reacting with our sodium hydroxide here, producing our salt, which is sodium acetate, and water. So the water came from here and from here. Those two are going to go together to make HOH, or you guessed it, water. And then these two are going to go together to make our sodium acetate, right? So again, we just need to find the H from the acid, the OH from the base, put those together to make water, and then whatever's left over, we put together to be a correct ionic compound, which again, we just generally call a salt. So here we have an aqueous solution of hydrochloric acid and calcium hydroxide. So again, I'm going to take that, and I'm going to make water out of that. And then what do we have left over? We have a chloride and a calcium. The calcium is the metal, so it's going to go first. Calcium is a +2. Again, I know that because it's right there, but also because it's in the second column of the periodic table. And chloride goes right here. Chloride is a -1. Therefore, again, this would go down here, and I would end up with CaCl2. That is the ionic compound of calcium chloride, or the salt calcium chloride. All we need to do now is, well, we would normally balance it. I'm going to go ahead and do that just for completeness sake. We have two hydroxides over here, so because I'm going to need two waters, that gives me, let's see, so I would need 2 here, and now we have a balanced chemical equation, okay? So again, really nothing very difficult. It's just a process. You find your H, you find your OH, you put those together to make water, and whatever you have left over. We have a sulfate and we have a lithium. Lithium is the metal, it goes first. Sulfate is the anion, it goes last. Sulfate has a charge of 2, so I'm going to put that 2. Lithium has a charge of 1, so that does not need to be written. So it's Li2SO4. To balance this, we have 2 H's, we have 2 lithium, so I'm going to need that, and now it's a balanced chemical equation. All right, the next one again, magnesium hydroxide is MgOH2. Why 2? Because magnesium is in the second column of the periodic table, so it has a +2 charge. So that 2 would move behind the hydroxide. Mixed with nitric acid. Nitric acid again is HNO3. That's in your note packet. It is going to react. Again, there's my H, my OH to make water, and whatever else is left over, which I have a nitrate and I have a magnesium. Magnesium is the metal. It's going to go first. NO3 goes last. Magnesium has a charge of 2, like I said before, so we need a parentheses 2, and nitrate has a charge of -1, so it's just MgNO3 parentheses 2. Okay, again, to balance this, just to be thorough and correct, we have 2 hydroxides, meaning we're going to need 2 waters, and if we have 2 waters, we're going to need 2 nitric acids, and that should be balanced, and it is. The next one, we have chloric acid, which is HClO3. Hydrogen chlorate is going to be mixed with potassium hydroxide, KOH. K has a +1, hydroxide is a -1, so that's all there is to it. Again, my OH and my H will go together to make water, and whatever else is left over, I have a K and a ClO3. K is a +1, first column of the periodic table. Chlorate is a -1, so it's just KClO3. That is my salt or ionic compound called potassium chlorate. And again, it should already be balanced, and it is. Okay, so those, like I said, this is really not that difficult. You're just pulling out the water, seeing where that comes from, and then putting whatever else you have left over together to make our water and our salt. Last one, it says write the balance equation for wind. That sounds funny. Hydrobromic acid, that's HBr, or hydrogen bromate, or bromide, excuse me, is mixed with magnesium hydroxide. Again, we already did magnesium hydroxide. It's MgOH2 because magnesium, second column of the periodic table, has a charge of 2. It is going to react together. We have our acid, our base to make our good friend water, and what is left over, we have magnesium and bromide. Magnesium is the metal, it goes first, it's a +2. Bromide goes last because it's a -1. Therefore, the 2 from the magnesium would move back behind there, giving us MgBr2. And then all we need to do now, of course, is balance it. I see 2 hydroxides here, so I'm going to need 2 hydroxides. That gives me 2 H pluses, so 2 H pluses. That gives me 2 bromides. I already have 2 bromides. It is now balanced. So as you guys can see, neutralization reactions are very, very simple to predict. You are always going to get the same 2 products. One of them will be water, and the other one will be whatever's left over, which will be an ionic compound. Make sure you put the metal, the positively charged one first. Make sure you put the anion non-metals last. Make sure you get the correct charges from the periodic table. Sorry, guys.